Hi, this is part two of the nervous system, and this video will be about nerves and a couple of nervous system disorders since we learn about disorders. So, what is a nerve? A nerve is basically a group of neurons, and it could be a very large group, which thousands of neurons covered in protective covering. There we go. And so we know that you have the brain and the spinal cord. And if you have a bunch of neurons and axons bundled together in the brain and spinal cord, we don't call those nerves, we call those tracts. So nerves are going to be the tissue that exits out of the spinal cord, right? And once it's tissue that's leaving the spinal cord, and here you can see these are backbones, which are vertebrae, and through the center of every vertebra, that backbone, it has like a hole like a donut has in the center, and that allows the brain to connect to the spinal cord, and then the spinal cord is protected by the backbone, so that's the central nervous system, and this is the side view, right, a sagittal view. If we look at sort of a posterior view of a person, we can see that the spinal cord connects to these nerves. And they're nerves because they're no longer in the spinal cord, and they're projecting out from the spinal cord in the gaps between all the vertebrae, all these backbones. If you took a piece of a spinal cord and you sliced it like a slice of cookie dough and you looked at it, it would look like this, and it would have what we call white matter on the outside, this area, and then in the center it would have gray matter, and that's just the way the spinal cord would look. So this is anatomy. What do nerves look like, and where would we find them? So this is a variety of pictures that show gray matter. Here it looks black, but if you're an actual spinal cord, to have a grayish color, and then the white matter, which actually have a whitish pinkish color. Brain matter actually looks fairly gray. The spinal cord looks fairly white. You might have seen it when you've eaten chicken or something. And so here you have let me get my pointer here. You would have the tube of the spinal cord, and then if you had a cross section of that tube, it would appear this way. And once again, we don't call them nerves. We're in the brain. We call them tracts. So we're talking about not the brain. We're talking about neurons that are exiting the spinal cord, not in the spinal cord, not in the brain. And they might have gray matter, which would be the unmyelinated part of a neurocell, a neuron, because there's no myelin here. And that's what makes it sort of the gray color. Or the other way to think about it is that the myelin, which is fat, is going to have a white color. And so notice a cell body doesn't have myelin, so we say it's unmyelinated. And then the dendrites never have myelin, so we say they're unmyelinated. So the anatomy of a nerve is like this. And actually, I'm going to start with the bottom, though I can't move my pointer. That thing's going to block it. So if you look down at the bottom, you can see an axon, and you can see how the Schwann cell wraps around the axon in the peripheral nervous system. And then wrapping around that Schwann cell, around that neuron, you have something called an endoneurium. And the word endo means inside, and ner means nervous. So it's describing where you would find this tissue, and we call it fibrous connective tissue. Fibrous because it's sort of tough, and if you remember from the cancer unit, we said tissue is in different types. There's nervous tissue. We will get to muscular tissue. There's epithelial tissue, and there's this stuff that's called connective tissue, which is mostly stuff that cells make and less cells. Whereas if you look at epithelial tissue, it's a lot of cells. So cells make the stuff that's fibrous, it's sort of tough, and it's used to cover many body parts. And this is one type of tissue it covers is nerve cells. And then if you take a bunch of those and then you take them together like a can of pencils, if you can imagine a can of pencils, or maybe a can of spaghetti, and you stand it up, and then you wrap around that, you wrap some more protective fibrous connective tissue around that. We would call that group a fascicle. And if you look down at the bottom, I can't move my cursor, and that circle, it's sort of a pink color with a black circle around it, it says fascicle. And so there's fascicles inside one nerve. So a nerve has these bundles here and here and here and here, and these are all fascicles, which are full of neurons, which have been wrapped in an endoneurium. And every fascicle, this pink color here that goes around it, is called a perimeter, perineurium. Usually I don't say perineurium. Maybe some people do. Perineurium is going to go around the fascicle, and so it holds them together. And then this nerve, here would be a piece of the spinal cord with the gray matter and the white matter, and these are nerves exiting between the backbones. Here we'd have, this would be the nerve. It's covered in this thing called an epineurium, and you think of like epidemic, epidemiology, covering a large group, a population, right? So perimeter surrounding, epi is like a population, and endo's inside, and this is just nerve anatomy. It doesn't really come up that much in this class, but if you think about if somebody has damage to nerve, maybe they cut something and a nerve got cut, or there's some kind of an injury, depending on how deep that damage was it, or was it an infection or something that got in there, that this can be predictive of how much damage happens to the nerve and how well they heal. A common nerve disorder is called multiple sclerosis, or it's not rare. It's often referred to as MS. Multiple obviously means many, and sclero means hard. And what happens when a person has multiple sclerosis, as they start to lose myelin in their central nervous system. Remember, the oligodendrocytes are the name of the cells. Site means cells that put myelin around neurons in the central nervous system, and they become demyelinated. They start to lose that myelin, and this makes them unable to send their messages and communicate. And the whole point of having a neuron is to communicate. So the oligodendrocytes get injured, and I'll explain sort of, we don't really know why that is very well. And then the sclero comes up with this plaque-like lesion. A lesion is an abnormal area. If we say something's a lesion. And so where it used to have healthy tissue, now it's got sort of this hard plaque-like lesion, which can often, we see in many body parts all over the place, which we might call scarring. And this is also because you have your inflammatory response going to that area and causing this to occur, which is a bad thing. So it's an inappropriate inflammatory response, which causes this damage, makes it become sclerotic and hard, and it can no longer do the job. So why is it that some people get it? Notice now the neurons can't send their messages. And so what you might see is people start having numbness and tingling in their hands and fingers. Then they become less coordinated, more difficulty using their arms and their hands, more difficulty walking. And they might eventually, over many years, end up with having visual and speech impairments, and thinking impairments, and many other things, fatigue. And so it's an unknown cause. So we'd say it's idiopathic, other than the fact that we know that the immune system, which should be fighting bad guys and invaders and bacteria, are cleaning up toxins and removing them, becomes activated against the cells of the body. And the problem with that is you can't stop the immune system, because you need your immune system to fight infections. So there's no real way to stop it unless you try and address why they're doing this here. So this is saying this shows this is a normal myelin sheath and a normal nerve fiber. And here we have a scarred one, where it now has become scarred and sclerotic. And so this disorder tends to be relapsing, meaning the person will get really bad for a while, could be weeks or months, and then they have these prolonged times where they're not so bad. They seem to stabilize, and that could go on for years, and then they have another bad bout. So this is a very long-term chronic, this is what we would call a chronic disease, that it occurs over many years. The opposite of chronic would be acute, like a short-term thing, like having a cold or a flu or a broken bone, where it'd be a relatively short term, and then it would go away and you'd heal. Another fairly common nerve disorder is called neuritis, and an itis is an inflammation, and it's an inflammation of a nerve. And a really common one is called sciatica. That's how you pronounce this word, sciatica. So it's a type of neuritis, and this is the sciatic nerve. It's a really big nerve that exits the lower back. This is the pelvis, and travels down the back, and it communicates to the leg. And so if this becomes inflamed for whatever reason, sometimes it's not know why, it can be extremely painful, and it says sort of shooting pain down the entire leg. And these are areas that will be affected when this nerve is inflamed. So it's called sciatica. It's fairly common in people who sit too much, like truck drivers or cab drivers or drivers, but really anybody can have it. And it could be the result of poor shoes or all kinds of stuff. And there's really nothing you can do about it once that nerve gets inflamed, not neuron, sorry, the nerve gets inflamed, other than sort of wait for it to get uninflamed and try and block the cause. That's it for this video, and I will continue into reflexes with the next one.